In this video, we will cover lesson 1-6 from Secondary 1 Math, solving rational equations. A rational number is a number that can be written as a fraction. So if we talk about a rational equation, we're looking for something with a fraction. So x plus 2 over 6 equals 3. This is a rational equation because it has a fraction in it. So let's look at an example. Number 1, x plus 7 divided by 8, there's our rational part of our equation, equals 5. So what we're going to do is we're going to multiply both sides by 8 to get rid of our rational expression in the equation. So we're going to multiply by 8 on the right and on the left. Now on the left I'm going to put 8 over 1 since we're multiplying it to a fraction. But 8 divided by 1 is just 8, so they would be the same. I'm doing the same thing to both sides of our equation. Now, if I multiply by 8 and divide by 8, that simplifies to 1. So it's just like multiplying or dividing by 1, and 1 times x plus 7 is x plus 7. Now, on the other side of the equation, 5 times 8 is 40. So we have x plus 7 equals 40. To get x by itself, we're going to subtract 7 from both sides so that we have x on the left side of our equation, and 40 minus 7 is 33. So in set notation we write it as x such that x equals 33. Now number 2, we see a similar setup. We have 1 minus n divided by negative 2. So there's our rational part of the equation, equals 15. So our denominator here is negative 2. So that's what we're going to be multiplying to both sides of our equation. So we have negative 2 and negative 2. Now on the left we have a fraction, so I'm going to put it over 1. And now we're going to simplify. So on the left we have negative 2 times 1 minus n divided by negative 2. Since we're multiplying and dividing by negative 2, that simplifies to 1. So we have 1 times 1 minus n, so 1 minus n. Now we have 15 minus 2, or not minus, but 15 times negative 2, which is a negative 30. That's a common mistake, is to forget what we're doing if we don't write it clearly. Next up, we got to get n. We're solving for n, so we want to subtract 1 from both sides, and that would leave us with negative n. Don't forget to bring the sign with that n. Equals negative 31. So how do we undo it? We don't want negative n, we want positive n. So to make it a positive, we can multiply both sides by negative 1. And when we do that, negative times negative is positive, 1 times n is n, negative times negative is positive, 1 times 31 is 31. So we have n such that n equals 31. So go ahead and look at number 3. It's 9 equals 3 minus 5r divided by negative 8. And pause the video and try to solve this problem. Now that you've had a chance to work through this problem, let's just walk through it real quick. Here, 9 equals 3 minus 5r divided by negative 8. So I'm going to multiply by negative 8 on both sides of our equation. And I'm going to put it over 1 just so I'm clear. Negative 8 is being multiplied to the numerator of our rational expression. So on the left, negative 8 times 9 is negative 72. And if I multiply by negative 8 and divide by negative 8, that simplifies to 1. So I'm just multiplying by 1, which gives us 3 minus 5r. Next up, solving for r, we'll get rid of the 3. So I'm doing the addition of 3, so we're subtracting 3 from both sides, which gives us negative 75 is equal to negative 5r's. Don't forget to bring that sign. And now we're going to divide by negative 5, since we're multiplying negative 5 to r. And that will give us r is equal to negative 75 divided by negative 5 is going to be positive 15. In set notation, that will be r, such that r equals 15. Okay, so number 4, this one's a little different because we have x divided by 3, which is a rational expression, equals 5x minus 2 divided by 6, which is also a rational expression. So we have two denominators here. And this is where our warm-up comes in for this lesson. We want to find the least common denominator of our two fractions. So what is our least common denominator? If you remember from our warm-up, we just started using these two denominators and we'd count until we find one they have in common. But 3, if we count up 3 and then 6, well, those are the same. So our least common denominator is going to be 6. So we're going to multiply both sides of our equation by 6. I'm going to do 6 over 1 since we're dealing with fractions. And here we'll do 6 over 1. Now, to simplify on the left side, we're going to do 6 times x, but we're dividing it by 3. 6 divided by 3 is 2, so we'll have 2 x's. And on the right, we have 6 multiplying by 6 divided by 6. That simplifies again, like we've seen before, to 1. So we end up with 5x minus 2, because 5x minus 2 times 1 is 5x minus 2. Now get our x's to the same side so that we can solve for them. So I'm going to subtract 5x's from both sides since we have a negative 2 on the same side as 5x. So we get negative 3x's equals negative 2. Now we have negative 3 times x, so we're going to divide by negative 3 and get x equals 2/3, since a negative divided by a negative is positive. Inside notation, x such that x equals 2/3. Alright, so let's take a look at number 5. We have negative z over 10 equals 3z plus 8 over negative 30. Alright, so this one, you can see we want to look for something in common of, we're looking for an LCD, or least common denominator, of 10 and negative 30. Now, we're going to have to kind of ignore, when we're looking for our least common denominator here, the sign. And we're just going to keep it as a negative. That way it'll eliminate our negative in our denominator. But 10 and 30, well, if we count by tens, we go 10, 20, 30. Well, that's 30. So negative 30 is going to be our least common denominator. So let's go ahead and multiply both sides of this equation by negative 30 over 1. Alright. So on the left, we have negative 30 times negative z, which makes it a positive 30 z's. And then we divide that by 10, so we end up with 3 z's. Next, we have 3z plus 8 divided by negative 30 times negative 30. So those simplify to 1 because we're multiplying and dividing by the same thing. So 1 times 3z plus 8 is 3z plus 8. Now subtract 3 z's from both sides to get the z's on the same side, and we get 0 equals 8. But this is a false statement. This is not true. 0 does not equal 8. So this is no solution. It means there's no solution to our equation. We write that in set notation as an empty set of braces. Okay, number 6, we have 5m divided by 4 equals m minus 3 divided by 3. So the first step we have to take here is to find a least common denominator, or at least a common denominator. And the least one, it just makes it easier because we're using smaller numbers. So if we count up, we got 3, 6, 9, 12, 4. We go 4, 8, 12. So 12 is what they have in common. And remember, we could just count it out. If we just counted up 3, then the next one would be 6, and then 9, and then 12. And then 4, that's a horrible 9. But then we have 4, and then 8, and 12. So 12 is the one that they have in common. So since 12 is the one they have in common, we're going to multiply by 12 on both sides of our equation. So I'm going to write it as 12 over 1 since we're multiplying fractions. And we're going to show what this might look like here if we expanded it out and wrote out what we're doing. So we're going to go with 12 times 5m over 4 equals 12 times m minus 3. Now I flip the 12 to the other side, still multiplication. It's going to be distributed here, divided by 3. But really, remember, 12 is just 4 times 3. So I can write it out as 4 times 3. And I can simplify the 3 on the right, simplify out the 4 to 1. 4 divided by 4 is 1. And then I can write what I have. So I have 15 m's is equal to 4m, because now I got to distribute here. So I'll put this in red, 4 times m and 4 times negative 3. So we end up with 4m minus 12. Now to continue, we're going to subtract 4 m's from both sides of our equation and get 11 m's equals negative 12. Dividing it by 11, and we find that this is our fraction for m, because we can simplify 11 divided by 11. So m is negative 12 over 11, writing it in set notation. In set notation, we have the set m such that m equals negative 12 elevenths. And that's it. So actually factoring down our 12 to 3 and 4 is helpful in simplifying this equation so that we can solve for the variable m. Let's go ahead and take a look at number 7 now. We have x minus 2 divided by 3 and 3x plus 1 divided by 5. So here, we're going to look again for that least common denominator. Okay. And so if we do it by 3's, we know we have 3, 6, 9, 12, 15. And 5, I know it was 15, so 5, 10. So this is going to be 15, our least common denominator. And remember, that's just factors to 3 times 15, which is really nice. And it can be helpful for us. So let's go draw our line down. We're going to multiply both sides here by 15. But instead of writing 15, I'm going to do 3 times 5 over 1. And so on the left, our 3's will simplify to 1. And so we have 1 times 5 is 5. And then we're going to distribute. So we're going to have 5 times x minus 2 on the right. And on the left, our 5's will simplify to 1. So we're going to have 3 times 3x plus 1. Now using the distributive property, we do 5 times x, so that's 5x, and 5 times negative 2, which is negative 10. On the right, 3 times 3x is 9x's, and 3 times 1 is 3. So simplifying, we'll subtract 5x's since it's smaller than 9x's. And that's just nice to have positives. So that gives us negative 10. Negative 10 equals 4x's plus 3. Subtract 3 from both sides, and we get negative 13 equals 4x's. And here we go. We're going to divide it by 4. So there it is. We can see what our answer is going to be. It's negative 13 over 4 equals x. In set notation, let's set x such that x equals negative 13 fourths. And we have it. Okay, so number 8, we have negative 4y plus 1 divided by 7 equals 8y minus 2 divided by negative 14. So again, we want to look for our least common denominator, okay? And here we have 7 and 14. I know if I count by 7s, it goes 7, then 14. So I know 14 is going to be part of my least common denominator, but I also want to make it negative since that's a negative in the denominator. So we're going to multiply both sides of our equation here by negative 14 over 1. Now, to be clear, I'm actually going to do this a little bit different. Instead of writing negative 14 on the left, I'm going to write it as negative 2 times 7 over 1. So now we can simplify the 7s. So here I'm going to write this in. We're going to simplify these 7s to 1, because 7 divided by 7 is 1. And we can write what we have left as negative 2 times negative 4y plus 1. And then on the right, we can again do the same thing. We're going to simplify out the negative 14, and this is why we made multiplied by negative 14. And that simplifies to 1, so 1 times 8y minus 2 is just going to be, this is nice, 8y minus 2. Now let's distribute negative 2. So negative 2 times negative 4y's is 8y's. And negative 2 times 1 is negative 2. So we have 8y minus 2 equals 8y minus 2. Now you may see it already, but let's go ahead and subtract 8y's from both sides to get the y's to the same side of the equation. And notice that 8y minus 8y is 0, so we have negative 2 equals negative 8, or 8y minus 8y is 0, so we have negative 2. And this is always true. This is always true. And so we know that all real numbers is our solution. Meaning all real numbers could be the value of y. Alright, so let's go ahead and look at number 9 and 10 here on the screen. So this one gets a little bit crazy because we have a fraction within a fraction, but we can still do the exact same things we've been doing. We just got to find a common denominator. And we always emphasize the least common denominator because then you're dealing with smaller numbers. So our least common denominator of 8 and 4. Well, if we count by 8s, it's 8, 16. If we count by 4s, it's 4, 8. So 8 is something they have in common. Since we have one with a negative, we want to have a negative in the number that we're going to be multiplying by. So negative 8. So let's go ahead and multiply both sides of our equation here by negative 8 over 1. Now on the left side, again, I'm going to write it as a factored form. So I'm going to do negative 2 times 4, which is 8 over 1. Okay, so let's go and simplify. Here we have on the left, 4 divided by 4 is 1. And so we have negative 2 times 1 is negative 2. Now I'm going to have negative 2 times 3x, or 3x's, plus 5 halves. On the right, negative 8 divided by negative 8 is 1. So we're actually not changing this numerator. It's just negative 7x's plus 2. Because we're multiplying by 1. Now we're going to distribute the negative 2 on the right side of our equation. So negative 2 times 3x's is negative 6x's. And negative 2 times 5 halves would be negative 5. So we have negative 6x's minus 5 equals negative 7x's plus 2. So I'm going to add 7x's to both sides. And that will give us 1x minus 5 equals 2. So if we add 5 to both sides to get x by itself, we get 7. So x equals 7. In set notation, we write this as x such that x equals 7. Alright, so number 10. We're looking to do the same thing. We have a 10 and a 4. So we're going to look for the least common denominator between 10 and 4. So think about tens. Let's find something that's divisible by 4 that is a 10. So we can count up by tens. We go, let's see, 10, 20. Oh, 20 is divisible by 4, so we're going to use 20 as our least common denominator. Now, 20 is 4 times 5, so I'm going to write 4 times 5 over 1. That's what I'm going to multiply by on the right side of our equation. And on the left, I'm going to multiply by 2 times 10, since 2 times 10 is 20 over 1. And now I can multiply and simplify this out. So let's go ahead and do that. We have 10 divided by 10 is 1. And so 2 times 1 is 2. So we're going to have 2 times negative x plus 3 equals. And on the right side, 4 divided by 4 is 1. So 5 times 4 is 5. Times 2 is 10. So we have 10. We're going to distribute that through x plus 3. So let's go ahead and distribute. 2 times negative x is negative 2x's. 2 times 3 is 6. And then on the right side, we're going to have 10 times x, which is 10x's, and 10 times 3, which is 30. So let's add 2 x's to both sides to get x's to the same side of our equation, which leaves us with 6 equals 12x's plus 30. Now we're going to subtract 30 from both sides, which gives us a negative 24 equals 12x's divided by 12. And we have x is equal to negative 2. So in set notation, we say x such that x equals negative 2. This concludes Part 1 of Lesson 1-6 of Secondary 1. That's examples 1 through 10.